Hello and welcome to our Webinar Wednesday e-learning session. My name is Kenny Kashiwada. I'm one of the applications engineers with Hawkroot Systems. And today we're going to take a look at what's new in 2014 with the SOLIDWORKS analysis tools. As you're probably aware of, SOLIDWORKS offers a wide range of design validation products, which includes SOLIDWORKS simulation, flow simulation, sustainability, and plastics. We're just going to be focusing on the main highlights within each one of these products, starting with SOLIDWORKS simulation. Those enhancements include the ability to automatically convert your toolbox fasteners to bolt connectors, a new plot called contact visualization. When looking at our results, we can now mirror our results when using symmetry fixtures. We can look at a contact pressure plot in a 2D simplification study, and my personal favorite, just an overall improved workflow when creating your result plots. So we can now automatically convert our toolbox fasteners to bolt connectors when creating a static or nonlinear study, and this functionality is only available with Simulation Professional licenses and above. So in my assembly here, I have 4 different toolbox components, 2 bolts, and then 2 nuts. And previously, the workflow would be to suppress these 4 components, start a new study, and then manually create the connectors. Now, I'm just going to create a new static study, but at the very bottom under options, we have the ability to check the box to convert toolbox fasteners to bolt connectors. When I click OK, it's going to scan my assembly looking at the fixtures, and I get a message telling me that 2 simulation bolt connectors were successfully created. And I can see them in my connectors folder. And when I expand the parts list, I get an additional folder showing me the components that are being excluded from the analysis since they were converted to the connectors. If I edit the definition on one of these bolts, we'll see that the corresponding edges and size of the bolt and nut were inputted automatically. It also pulled the material information from the toolbox fasteners as well as the strength data and preload. Okay. After we run a study with any connector, we now have the ability to say list connector force. Previously we just had the option to list pin bolt bearing force. And we see that this new connector force is part of the result force menu. So when I click on any of these rows, we'll get a flag appearing pointing us to the location of the connector with the corresponding forces. The other great thing about this is now we can also show the forces in spring connectors, spot welds, and links. So we're not just limited to just looking at the pins, the bolts, or the bearing connectors. For this assembly, I also wanted to take a look at some of the changes by modifying this front plate here. So right now I just have these 2 slot cuts. But what happens if I didn't have any cutouts at all? How would my stress be affected? So I have an additional simulation study and configuration for this. So I need to go to that study, activate the SOLIDWORKS configuration, and then show my stress plot to try to compare the results between those studies. I also have one where I have 4 vertical slots. So again, need to activate the study, activate the SOLIDWORKS configuration, then show my stress plot. In SOLIDWORKS 2014, we can now use the compare results tool to compare the results of our simulation studies across all of the different configurations for our model. Okay, previously we could use this tool to compare the results of all the studies just with one configuration. Okay, so I'm going to click OK, and now we get this nice tiled view showing me the results of all 3 of those studies within one graphics window. Okay, so no more switching between studies, activating the different configurations, showing the plots, and trying to compare them that way. Now we can do it just within one window here, saving us a lot of time. Okay, so we saw the ability to automatically convert our toolbox fasteners to bolt connectors, the new list connector force menu, and the ability to compare results across configurations. We can also enable this new plot called contact visualization, which is going to allow us to easily look at all of the different contacts within our study. Okay, not just the global contact conditions, but also the local contact sets. Again, this functionality is only going to be available with Simulation Professional licenses and above, but it's going to be a real time saver just to make sure that we do have all of our contacts properly set up within our analysis. Okay. So in this study, I manually created bonded contacts between all of the different faces. So I'm going to right click on connections and enable this contact visualization plot. Okay. I just need to press calculate, and now I see all of the faces highlight that have that bonded contact, and I can click on each one in the list to see which faces are indeed being bonded together for that contact set. Okay. Previously, if I wanted to get an idea of which faces would be bonded with just the global bonded contact, we could have ran interference detection treating coincidence as interference. But that wouldn't really help me if I had any gaps in my model where I manually created the contact sets, or if I wanted to see where the different contact types are. So if I had some no penetration contacts, those would also highlight here in a different color. If I just wanted to see the contacts between certain bodies, I can just select them from the graphics window, press calculate again, and now it's pretty obvious that I indeed forgot to create one contact set between these two plates. So I definitely want to do that before running my study. Also, for this study, I use this symmetry fixture, and if you notice when I activated my stress plot, I can now see my stress across the entire model, not just the half that we actually meshed and run using the symmetry fixture. The reason for this is if I go to edit definition of my stress plot, under advanced options, we now have this checkbox to display symmetric results. So if I uncheck this, press OK, now this is what we used to have previously, just looking at our results on the actual model that we meshed and set up the study for. But with this symmetry fixture, just go to edit definition, go to advanced options, and say display symmetric results. Okay, so that was our mirror results across planes of symmetry. And now here's my favorite enhancements within SOLIDWORKS simulation, and just small little changes, but they're going to greatly improve the usability in creating your result plots. For example, we now have combined access to the edit definition, chart options, and settings within the same property manager. We can modify a lot of these values just by right clicking on the legend, and we can dynamically change the minimum and maximum values of our legend just by clicking on that value in the graphics window. Okay, so first, you might have noticed this when I went to edit definition of the stress plot, but if I go back to that, I now have the tabs to modify the chart options and settings within the same menu. So if I wanted to go to like a discrete color plot, maybe change my chart options to a user-defined scale, say between 0 and 500. I could also change the number format to scientific. Right, and now I was able to modify all of those options again just within the same property manager. So you're not going to have to remember, well, where's that option to show my undeformed shape over my model, or where do I show my mesh, or how do I change the legend, how do I change the deformation scale, or the different stress types. We can do that all within the same menu, saving you just a lot of time and simplifying the workflow and just creating the result plot that you need. Okay. Few other options we have: if we just right click on the legend, we can now show the mesh, change the fringe options, or change the actual component of the plot that we're looking at. So here, instead of looking at the result and displacement, if you just want to see the vertical, we can switch to the Y displacement plot to again dynamically update our result plot. Okay, I can also right click, we can say show mesh to overlay our mesh over our model. And if I wanted to change the minimum and maximum values of my legend, I can just click on the value in the graphics window here and then just type in the value that I want. So I can say I want a max of 50 MPa, click the green check, and now my plot updates automatically. What if I want to find out where this maximum stress is? Again, click on the value on the legend, and we can click on the show annotation flag, and now I get my max annotation. I can do the same thing with the minimum. If I want to turn any of them off or reset them, just click on the value again. If I want to go back to my overall max stress, just reset the maximum. Click OK. Okay, so again, just a lot of small changes, but really huge time savers when you're setting up your result plots. Just changing the min-max value of your legend, enabling the minimum maximum annotation flag, showing the mesh from the right click menu, changing the actual type of result from the right click menu, or when you actually do go to the edit definition, chart options, or settings, you'll have tabs to change all of those options within the same property manager. Okay. If you set up a 2D simplification study, again, this functionality is available with SOLIDWORKS Simulation Professional and above, we can now look at a contact pressure plot. So here I have this latch assembly, and I want to run a nonlinear study to show my latch closing and opening, and I want to see the forces as this latch locks. So I have a 2D simplification study, nonlinear study already created, and we can look at the stress and displacement. But for the stress plot, we also have this contact pressure. Okay, so if I show that, we'll see the vectors of the contact pressure between our two bodies, and we can animate the plot. To see the contact pressure update as our latch is closing. Okay, so we always had the ability to show this contact pressure plot in just a stress analysis, but we can now do so in a 2D simplification study. With a Simulation Professional license and above, we now have access to additional material models. That's through this materiality material database, which you can find online. So when you go in and say apply edit material, there will be a link on the bottom left saying click here to access more materials. Okay. It's going to bring up a web browser, and we can now search for additional materials based off the type of simulation study we're running and the type of material model I want. So let's say I want some material with a stress strain curve so I can get plastic deformation. So we can go to plasticity von Mises, choose the type of material. Maybe I want to look for some additional metals. Then I just need to press locate materials. It's going to search the database and then give me a list of all of the different materials that match my search criteria. Okay, so say I want to look at a 2024 aluminum, just click on the icon. Another window will pop up so I can see the actual material properties. Come to the tables and curves tab and actually see the stress strain curve for this 2024 aluminum alloy. Okay, then I just need to download this, then I can load it in my material library and then use this in any of my studies. In terms of performance, there's again quite a few enhancements. The main one being an additional solver type that we call a large problem direct sparse solver. Okay, so when you start to run large studies, here we're getting up to a few million degrees of freedom. The direct sparse solver previously would fail. But now we have access to this large problem direct sparse solver, so we can now solve those large studies. And even what studies that did solve with the direct sparse, they're just going to be quicker using this additional solver type. Also, just for like the iterative solver or FFE plus, again, you're going to see performance increases or solution time decreases just when you run your different studies. Alright, now let's switch gears and take a look at flow simulation. The main new enhancement with flow simulation is just an overall tighter integration within CircuitWorks. So if you do any sort of electronics cooling, this will really be a useful enhancement for you. So I have my imported ECAD model using CircuitWorks into SolidWorks, and if we take a look at the properties for some of these components, we'll notice there's additional material properties, so density, specific heat, thermal conductivity. There's also this volumetric heat generation rate property that's applied to some of these components. Okay, so if I come to the CircuitWorks drop-down options properties, we'll see the different material properties that can be imported from your ECAD file into CircuitWorks and SolidWorks. So what this will allow us to do is when we set up a flow simulation project, we can now scan all of the components and then look for those material properties or heat generation rates and have the SolidWorks automatically create those solid materials for us and heat sources. Okay, again, just saving you a lot of time and any potential user input error. So I'll come to my flow simulation. I have a new project here. So now I would want to try to import some of those properties to my project. So just come to the flow simulation drop down, tools, and we can say import data from model. Okay, it's just going to scan all of the different parts in my assembly, and it'll give me a list of all the different materials and volumetric heat sources that it found. Okay, so we can see it's quite an extensive list here. Just press import, and now it's creating those solid bodies, solid materials, and volumetric heat sources for me. Okay, so we can see all of the solid materials it added. Scroll down further, all of the heat generation rates, and you can see it created over 180 different heat sources for me. Previously I would have had to manually select all of the bodies and be sure I input the correct values for each one of these components. Now, since they're just properties from the ECAD file imported through CircuitWorks, we can just have SolidWorks create these heat sources for us automatically. Okay, so we can take a look at some of these results. We can show our cut plot, look at a surface plot, looking at the temperatures on my board and components, and our flow trajectories. Okay, so now that we have our results, and how can we share this information with other people? You may be familiar with eDrawings, a way that you can share your model drawings with other people without needing to have SOLIDWORKS installed. We can now do this with flow simulation, and I can send them all of these flow result plots within one file. So if I come over to eDrawings, we see all three of those result plots that I just had have the ability to hide any of these. Okay, you can still have access to rotate the model, move things around, show the different plots. Okay, so again, just a tighter integration between the different products. We can, within eDrawings and flow simulation, we can now export multiple results to a single eDrawings file. Okay, so here are the different properties that we can import from CircuitWorks into flow simulation. We saw the improved eDrawings plots. In terms of performance in flow simulation, the mesh process can now utilize multiple cores in your processor, so you'll see significant speed increases if you do have a multi-core processor. Okay, the solver was always supported multiple cores within the process, but the mesh can do so as well in 2014. So again, just overall speed increases when running your flow projects. If you use the solution adaptive mesh within flow simulation, we can now do that at a local level. So if you have any local initial meshes, you can turn on the solution adaptive mesh just for that local mesh and not globally. And there's a few other usability improvements, such as the leak tracker being available from the graphics window. We can now change multiple boundary conditions or heat sources at once. So if you wanted to just change the wattages of all your heat sources, you can shift select them and edit the magnitude of it. And for the ambient velocity, we can now specify that in terms of aerodynamic angles instead of manually specifying the 3D vector for velocity. Okay, so if we come to the calculation control options refinement, we now see we have the ability to apply the mesh refinement just at the local initial mesh level. If I wanted to just modify a few of these heat sources at once, just shift select them. And when we edit definition, we can change the magnitude of all of these. So we can say all these are going to be 0.1 watts. And if we come to the general settings, the initial ambient conditions, for the velocity, instead of defining it by 3D vector, we can specify the velocity off aerodynamic angles. Okay, so those were the highlights with flow simulation. Finally, now let's look at SOLIDWORKS Plastics. So within Plastics, they introduced quite a few new wizards, again, just trying to improve the usability of these projects. So now there's a getting started wizard. They completely redesigned how we define runners within a Plastics project. Again, just going to save you a lot of time. The dynamic result advisor gives you a lot more feedback on the results of your Plastics project. But really the main enhancement is, again, tighter integration between SOLIDWORKS Plastics and SOLIDWORKS Simulation. So we can now export the residual stresses and temperatures from after the packing process with Plastics Premium, and you can now run a nonlinear static analysis using those residual stresses or in-mold stresses from Plastics to see how your part will react to those residual stresses and temperatures. Okay, so let's take a look at this iPhone cover. So first, just to get us started with setting up and running our plastics project, we can enable the Getting Started wizard. So if you're familiar with like the Simulation Advisor, it's going to be a very similar workflow, just taking us step by step of what we need to do to actually set up and run our project. So we can create our mesh. Okay, we can use the automatic settings. Looks good, so we can accept it. Going back to our wizard, now it's going to say, well, what material do we want to use? It'll show us the material with the melt temperature, mold temperature. Just clicking change material will bring up the material library, so we can change our plastic. Next, well, what's the machine details? So we see the fill time, the injection pressure. Again, this fill settings menu was revamped, so we can easily change any of these options. If we come to the advanced, we'll see the machine database and machine properties, so we can modify those as well. And next, we just need to specify where's the injection location. Previously, this was just called the gate location, so we just say add injection location. We can pick a point, and we can also ask for the predicted flow pattern of this injection location. Okay, so that looks pretty good. We'll click OK. And now we just need to run this plastics project. All right. Mentioned they redesigned how we define runners within plastics. So if we come to the runner design wizard, I no longer need to have sketches for where I want my sprue runner and gate locations to be. I can now select the runner type and then manually just click on some locations, and then from the property manager, the wizard, I can specify what diameters and lengths I want for the sprue, runner, and gates. Once we have a plastics project with results, we can come to the dynamic result advisor, and this top section here is going to give us a lot more feedback on the performance of our part, and some suggestions of how we can improve the performance. So at the very top, we get our stoplight icon telling us the ease of fill. Then it's also going to tell us what the injection pressure was, how it compares to our machine, the different temperatures, and how that could affect our material selection. Okay, so again, just a lot of good feedback on what our result plot's actually telling us, and some feedback or suggestions to improve our overall part and mold design. Okay, so after running the pack process, we can look at the temperatures, the residual stresses, but we can now come to export these results into SOLIDWORKS simulation. So we can export the in-mold residual stresses just by clicking export, which would save out this result file. So when we come to a nonlinear static study and go to the study properties, we now have this tab that says in-mold stresses, so we can import the in-mold stresses from SOLIDWORKS Plastics. We can also include the material from SOLIDWORKS Plastics, so I can get more accurate results by using the actual plastic material properties between the two programs. Click OK. Now we see the in-mold stresses from plastics as my external load, and we'll be able to see what the displacements and stresses would be. Okay, animate our displacement plot to see how we'd expect our part to shrink. Okay, so we saw the getting started wizard, the new runner design wizard, the improved dynamic help advisor. But really, if you do have plastics premium and simulation premium, we can now import those temperatures and in-mold stresses from plastics into a nonlinear static study to predict how our part will shrink and the stresses within our part. So these were just the main highlights with What's New 2014 with the different analysis tools. But for more information, definitely would recommend going to the What's New guide just from the help menu. There's also an interactive guide with examples that you can go through. And the online help, just help, SOLIDWORKS help, will have a lot more information. And also just online my.solidworks.com will give you a lot more information and community support and advice for these different products. I also want to mention that we now offer simulation services at Hawk Ridge Systems. So if you do feel that you can use some more one-on-one mentoring with any of these products, or if you need help actually setting up and running any of these, we offer consulting even if you don't have a license. The real nice part is if you do use any one of our simulation services and you decide to purchase an additional license afterwards, 25% of that fee can be applied to that new simulation license. And I really just want to thank you for attending, watching our webinar. If you do have any other questions, please feel free to give us a call or email. Here's our contact information. Again, thank you for your time and have a great day.